In section 10.2, we're finding arc measures in circles. A lot of terms to start with. First of all, when we're finding arc measures, we need to know the central angle measures. And the fact that you have this word central, you're thinking center. And it is an angle with its vertex at the center of the circle. So here in this circle C, I have a central angle at vertex C. I could say angle ACB is a central angle because its vertex is C, the center of that circle. And the measure of that central angle is 100 degrees. Now the measure of central angles are going to be important when we talk about the measures of arcs. We have two types of arcs we're going to talk about. Well, actually three types, I guess. A minor arc. The fact that it's minor, you're thinking it's kind of small. A minor arc is named by its endpoints with two letters, arc AB, and you literally just put a little arc over the top. So when I'm talking about arc AB, I'm talking about this arc of the actual circle from A to B. There's arc AB. Now, the fact that it's minor, I was saying it's little, it's less than half of the circle is the idea. So this is a minor arc because it is less than half of the circle. And its measure is just the measure of its central angle. So if I want to talk about the measure of an arc, I'm talking angle measure of the arc, and it's the same as the central angle. So angle ACB that I was talking about before was 100 degrees. That means actually the measure of the arc AB is also 100 degrees. It's talking about the angle measure, how much of the circle is this arc taking up. And then when I talk about a major arc, notice I'm going from minor arc to major arc. This is an arc named with three letters, first of all, and the reason why is because it is greater than 180 degrees, is more than half of the circle. And I name it with three letters to indicate that, yeah, I am more than half of the circle here. So you start at A, you go through point D, wherever that is on the circle, to end at B. I'm going to pick a new color here. So I'm starting at A, I'm going through D to end at B. This is a major arc. If I start at A, I go through point D on the way to ending at B, which is the end of that arc. Okay, so major arc, more than half of that circle, which this definitely is. You have to have the endpoints at the ends of the arc and a letter that it'll pass through. The measure is greater than 180. What is the measure of arc ADB? Well, think about this. You know the full angle measure of an entire circle is how many degrees? Well, a whole circle is 360 degrees, isn't it? So in this case, ADB is everything 360 except for this 100 degrees. So I'm really doing 360 minus 100. The measure of arc ADB then is 260 degrees, so that I can add these two together and get 360 for the full circle. Okay, that would also be the measure of this central angle as well, 260 degrees. So difference between minor arc and major arc. First of all, minor arc is named with two letters. That way you know that it's less than half of the circle. And it has to be less than 180 degrees because of that. Versus a major arc, which is named with three letters to indicate that it is more than half of the circle, meaning it's greater than 180 degrees. And finally, we do have one more type of arc, and it's a semicircle. But it should make sense that a semicircle is half of the circle. But that does mean the endpoints have to be on a diameter. I don't have a diameter in this case, but if I extended this into a diameter, then the semicircle would be 1/2 of that circle. And of course, a semicircle would measure exactly 180 degrees. Generally, you want to name a semicircle with three letters, although sometimes you'll see it named with two, so that can kind of go either way. Let's look at some examples of finding some arc measures. Oh, and before that, one more thing. Arc addition postulate. We had segment addition postulate, angle addition postulate early in the year. Arc addition says that you can add the measures of two adjacent arcs to get a larger arc. So it says the measure of an arc formed by two adjacent arcs, meaning arcs next to each other, is just the sum or the total, or adding together, the measures of those arcs that are next to each other. And we'll see that with the example here. So I start out, let's say I want the measure of arc DB. So I'm going from D to B. It is a minor arc because it is two letters. Now from D to B, I notice that I have the central angle that applies because vertex is at the center, or C, going out to D and B. Now this central angle measure was 135. Therefore, I know that arc DB is also 135 degrees. And I will label that out here. Arc DB is 135. Okay. Next one, I want the measure of arc DAB. Now this is either a semicircle or a major arc because it is 3 letters. So I need to start at D, go through A on the way to B. And then you have to decide which way to go. If I know I'm starting and ending at D and B. Well, I'm not going to go this way because I have to go through A, it said. So start at D, go through A on the way to ending at B. What is the measure of that arc? Well, wait a second. This is everything of the circle except for arc DB, which I just found was 135. So I'm thinking a full circle would be 360. Arc DAB is everything but 135. So I'm going to do 360 minus 135, and I'm looking at, what, 225? Yep, 225 degrees for arc DAB. Okay, again, it was everything but 135, so I did 360 minus 135. Get rid of that. All right, next example on the measure of arc AD, a minor arc because it's 2 letters, so the quickest way from A to D would be right here. Now, 2 ways to look at this. Either I can look at the central angle for arc AD, which would be angle ACD, and I know that these two are a linear pair. They add up to 180. And I could say 180 minus 135 would be, what, 45 degrees? And I can know that because this would be 45, or I can look at the arc out here and say this is a semicircle. Because I have a diameter AB, this would be a semicircle or measure 180. So again, I'm doing 180 minus 135 to get what's left for arc AD, which would be 45 degrees in order to add to 180. All right, next example, a major arc because it has 3 letters, or maybe a diameter. Measure of arc ADB. Start at A, go through D to end at B. Start at A, go through D. So I'm going to go this way because I'm going through D to end over at B. Well, the endpoints, A and B, are a diameter. I just did half of the circle, a semicircle, which measures what? What's half of 360? 180. You can also think that's a straight line that I'm doing. This is our first semicircle that we've had. What about measure of arc? DBA. Alright, endpoints at D and A go through B to get to A. Start at D, go through B to get to A. So I guess I'm going this way because I'm starting at D, passing through B, ending over at A. That's a lot of the circle, so that's going to be close to 360 degrees. You know, it's everything of the circle except for 45 degrees. So I'm thinking a whole circle would be 360. I'm going to take away the 45 degrees that it's not a part of. That's the only part that we're not including. And that would be, what, 315 degrees there. And one more on this slide, measure of arc BAD. Start at B, go through A to end at D. Start at B. Looks like I'm going to go this way. I'm going to go through A to end at D. Wait a second, didn't I do that one already? Isn't arc DAB the same as BAD? All I did was flip the first and last letters. Yeah, this is everything in the circle except for 135. So 360 minus 135 would be 225. And we're good to go. Oh, another way to look at this. You know that this much of the circle is a semicircle, right? Arc AB here is a semicircle. That would be 180. So you could even do 180 and do arc addition. Add this much, add the 45 to it. Because together these two arcs make up that full arc that I'm doing there. And that would be 225. So either way, you can find that measure. Okay. Let's look at another example. We'll do a little more arc addition in this one too. I also want to identify each of these as a major arc, a minor arc, or a semicircle and find their measures. Remember that they can kind of trick you with semicircle and do 2 or 3 letters, so be careful that you're also looking at where these arcs are in the circle before you decide whether it's major, minor, or semicircle. Measure of arc TQ. So that 2 letters has to be less than half the circle. There's my arc TQ. First of all, it is less than half the circle and it's not a semicircle. So this would be a minor arc. What is its measure? Well, I don't know the central angle for that arc TQ, but could I find it? Notice I have a diameter here. These two angles then are a linear pair. They have to add up to 180 because of the straight line. So if this is 60, wouldn't this have to be 120 degrees to add to 180? Now I do have the central angle for arc TQ, so it must be 120 degrees. There we go. What's our next one here? Measure of arc QRT. Start at Q, go through R to end at T. Start at Q, go through R to end at T, so I have to go this way. Go through R, end at T. Alright, definitely a major arc because it is more than half of that circle. And what does it measure here? Well, in this case, I might say this is everything but 120 degrees. So for that one, I would probably do 360 minus 120. Now the whole circle would be 360. This arc, QRT, is everything but 120. So 360 minus 20, looking at 240 degrees for that arc. Okay. Next one, where we're looking at arc TQR. Start at T, go through Q to end at R. So I'm going to have to go this way. So I'm going through Q to end at R. Alright, look at that. This is the endpoints of a diameter T and R. So this is a semicircle. I can tell that that is half of the circle. And therefore it measures what? What's half a circle? 180 degrees. Or you could think 120 plus 60, right? Because if this is a central angle, I know that part of the arc is 60 degrees. Next one, measure of arc QS. Q to S, and 2 letters, so I have to go the way that would be less than half of the circle. This would be more, so I'm going this way around. Well, I know that this portion was 60 because I had the central angle was 60, so that arc is 60. I need to know what this portion is here. Well, can I find this angle measure? Use this diameter. I know that this is 80, so what does this angle have to be so that I complete my diameter or my linear pair of 180 degrees? Wouldn't that have to be 100 degrees? So that these two make up that straight angle of 180. And if the central angle is 100, then the arc is also 100 degrees, same as measure of that central angle. But then arc QS is 100 and 60 together, so I'm really just doing 100 plus that 60. This is arc addition, and QS is 160 degrees. Oh, and because it was named with 2 letters, less than half the circle, it is a minor arc. So we're getting good at doing the measures of these arcs here. What is the measure of arc TS? Here is arc TS. Definitely a minor arc. It's less than half of that circle. It's named with 2 letters. And the measure of that arc should be the same as the measure of its central angle, which is 80 degrees. Then arc TS is also 80 degrees. And for this picture, one more example. Measure arc RST. Start at R, go through S to get to T. So I have to go clockwise. Start at R, go through S, end at T. I just did half the circle, didn't I? Because TR is a diameter. Those were the endpoints. If you're doing half the circle, this is a semicircle. And of course its measure is 180 degrees, 100 plus 80 there. So looking at arc addition, measures of arcs being the same as the central angle. And looking at types of arcs, let's do a little more here. This is actually survey results from who would you most like to meet? So it's kind of a circle or a pie graph here. So an actor had 83 degrees, other 61 degrees, athlete 79 degrees, musician 108 degrees, president missing. Well, how can I figure out the angle measure here? I have everything but this angle. Notice there are no diameters, so that won't help me. But what do you know the angles in the entire circle should add up to? Shouldn't they all add up to 360? So 360 minus the others. I'm going to go ahead, I'm going to do this on the calculator. I'm taking, 360 for the total. I'm going to subtract the 108. I'm going to subtract 83, subtract 61, subtract 79. So I got rid of all these angle measures, and this is a small angle measure, so the number I get should be pretty small, and I did. I got 29 degrees there. Now we should be good to go to find all these arcs. Find the measure of arc AB. Oh, that's the one I just found. Its central angle I just discovered was 29 degrees. So there we go with that. Measure of arc AC. Minor arc. Quickest way from A to C would be right here. And if I want the entire arc there, I'm going to add the 29 degrees plus the 108 degrees. Remember, an arc is the same as the measure of its central angle. I'm adding 108 and 29 here, and I get 137. Alright, what's the next arc we're looking at? Measure of arc ACD must be a major arc. Start at A, go through C to get to D. So I'm going around this way. I'm going to have to add a lot here. 29 degrees, 108 degrees. So a lot of arc addition here. And finally, what's the arc here? The central angle was 83, so the arc for the actor was 83, so I also am adding 83 here. And I get 220 degrees for that arc measure. Alright, what's my next one? Oh, that's not what I meant to do. Okay. Measure of arc ADC must be another major arc. Start at A, go through D to get to C. I'm looking at which way to go. I wouldn't go through D to end there, so I'm going counterclockwise. Start at A, go through D, end at C. For this one, a lot of arc addition here. I have 79 degrees for an athlete because that was a measure of its central angle. Plus, the other was 61 degrees, so that arc is 61 out there. Plus, the actor was 83. I got to total all these up here, 79, 61, and 83. And I'm getting 223 degrees. And last one on this slide. Measure of arc EBC. Starting at E, go through B to end at C, another major arc. Looks like I'm going to have to go this way. I went through B, I'm ending at C. And again, arc addition, add up all the arcs along the way. The athlete was 79 degrees central angle, 79 degree arc. President was 29 degrees central angle and arc. Musician was 108 central angle measure and arc. And it looks like that's what I'm adding there, 79, 29, and 108. And I get 216 degrees. So working with central angles being the same as the measure of the arc and arc addition, one more topic we're looking at today is congruent circles and congruent arcs. Now for circles to be congruent, they need to have the same radius or diameter. I mean, really, radius and diameter are related pretty directly. For arcs to be congruent, you need two things. They need to have the same measure, meaning the same degree, right? Like both 100 degrees. And they have to be either in the same circle or congruent circles. If they're in the same circle, obviously the circles are congruent, or they have to be in two circles that are congruent. So I want to tell whether the red arcs are congruent in these examples. So do they have the same angle measure, and are they in the same circle, or are they in two circles that are congruent? Well, do these measures have to be the same? Are their central angles the same? Here's the central angles for those red arcs. What kind of angles are these, though? They're congruent because those are vertical angles. So since vertical angles are congruent, I know that the measures are the same. So checking that part off. And it's in the same circle. Same circle, check. So yes, these arcs would be congruent because they are in the same circle. So their size is the same and their angle measure is the same. So yes, they are in this case. What about in this one? We have two red arcs. Well, we have the same central angle, so they definitely have the same measure. Same central angle. same measure, but the other criteria is that they have to be in the same circle or congruent circles. These are in two different circles, and they are not congruent circles. Obviously, the radius of the little guy is smaller than the big one, so are the red arcs congruent? No, they're not in this case. So arc measures in circles today.